Okay, so before the break, we started the topic of level of service and capacity. We are doing it for the for what? For uninterrupted flow facilities. Okay, which are freeways, multi-lane highways, and rural two-lane highways. Okay, for in freeways, no intersections. In multi-lane highways and two-lane highways, we have intersections, but those are at least 2 miles from each other. Okay. Then we went through the definition of capacity, which is the maximum flow rate. We went through the definition of level of service, which gives you the quality of traffic flow, and it goes from A to F. A is the best one, and F is the good one, right? Okay. And then we went through what we mean by each level of service, A to B and C and D and E. Okay, so A means, as I said, the good one, and E is the capacity. Okay, we looked at this graph which tells us how speed changes with respect to flow. Okay, so you can see when the flow increases, the speed does not drop instantaneously. Okay, it maintains for a little while. You can see it here. The flow is increasing, but the speed is same as free flow speed. Then we have this curve. The point from where the curve starts, we call it the break point, and the curve ends at capacity. Because after capacity, the flow starts to decrease, so we don't want that. Okay. How do we get the speed in this curve? We have an equation for that. Before the curve, we know it is free flow speed. Okay. How to get this point? We have other equations for that. So as I said, the point is called break point. So break point for freeways, break point for multi-lane highways. Okay. The end point of the curve was capacity. How to get the capacity? Capacity of freeways, capacity of multi-lane highways. Okay. Free flow speed, you can measure it like you did for your term projects, the spot speed study. Or there are equations to calculate free flow speed. We will look at it in this chapter. Okay? Clear? Okay. If you have the curve, if you have plotted the curve, you can mark in the curve the region for each level of service. Okay? So, this is the region for level of service A. This is the region for level of service B and C. Okay? How did we get it? Using these densities. These densities are given in highway capacity manual. Okay? So these values are given. They are fixed. Okay? What this value means in this graph, this value becomes the slope. Why? Because density equals flow upon speed. So flow on the x-axis, speed on the y-axis becomes a slope. Okay? So when you take the density from highway capacity manual for any level of service, that density becomes the slope of this line. Okay, so you start a line with a slope of 11 from origin. Okay, and 11 is the density for level of service A. So the line becomes for level of service A. Okay, for level of service B, the limit is 18. So you mark a line with a slope of 18, and this becomes the region for level of service B. Okay. Some of the graphs are already plotted for freeways and multi-lane highways, but to use these graphs, our speed should match. Okay, so this graph is for which speed? Speed of 60. Okay, so you cannot use it for a speed of 61. Okay, if your highway has a free flow speed of 61, I cannot use this. Got it? And there is no interpolation. There is no interpolation. Okay, so you can, if your speed is 58, you cannot interpolate between them. Okay, the reason, because it's not linear. Okay, interpolation is linear. Agreed or not? Interpolation is what? Linear, right? x1 minus x2, y1 minus y2. This is what? Linear, right? Between 2 points. Okay, is this linear? This is not linear. So interpolation will not work here. Clear or not? Okay. Okay, the points where the lines are intersecting the curves, the lines for each level of service. Those points become those points give us the maximum flow rate for each level of service. Okay, so this is the line for level of service A. Okay, these points, which are the intersection points of these lines, they become the flow rate for A, the maximum flow rate for A. Okay, if you are up to this line, you are in level of service A. If you are ahead of this line, do you have A? No. Okay, so only up to this line is A, and only up to this line is B. Got it? Clear? Okay, so these intersection points become the maximum values of each level of service. Okay, and since the graphs are already plotted, so the maximum values are given here. Okay, for the plotted values, the intersection points are given. Okay, clear? Okay, now in this table you see there are two things mentioned. One is called speed adjustment factor, the other one is called capacity adjustment factor. Now this column is for what? Freeways. Okay, and this column is for multi highways. Okay, do you see SAF and CAF here? No, right? So these factors are only for freeways. Clear? Now what are these factors? Speed adjustment factor, capacity adjustment factor. Okay. When to apply these factors or when not to apply these factors? If you have these four conditions, no factor is required. Okay, if you have these four conditions, no factor is required. Okay, now for which type of highway we need the factor? Freeway or multi-highway? Freeway. Okay, multi-highway, no factor is required anyways. Okay, so we are only discussing it for freeways. Clear? Clear? Okay. On a freeway, if these four conditions exist, then we don't need a factor. Okay. Any of these conditions do not exist, then we need a factor for that one. Okay. This table shows you which factor is required when. Okay. So if you have a problem with weather, if you don't have good weather, then you need capacity adjustment factor and also speed adjustment. Okay. If you have a traffic incident on the highway, then you need capacity adjustment factor, but you don't need speed adjustment. Clear? And same thing for the other two. Okay. Now there are three factors out, so there are total four, right? There are total four. Out of these four, three have tables. Okay, three have fixed values. You know the condition, go to the table, find the value. Clear? Where are the tables? I showed you last time as well. These are the tables. Okay, so there's a table for weather, there's a table for incident, there's a table for driver, population, and so on. Clear? Okay. Yeah. The only factor which requires calculation is the factor for work zone. Okay, what is the work zone? Any construction and maintenance activity which happens on the road or close to the road. Any construction maintenance activity happening on the road or close to the road. That is called a work zone. Okay, so if your highway has a work zone, then we need to calculate its adjustment factor. Okay, and this adjustment factor is for capacity and speed both. Okay, it is for capacity and speed both. Okay, let us look at how you calculate. First of all, the first thing I need to calculate is CWZ. What is CWZ? Capacity of work zone. CWZ is capacity of work zone. Okay. How do we calculate it? You can see the equation, very simple equation. I need two things, right? Okay, I need QDR and I need alpha. Okay, QDR and alpha. Alpha is the reduction in capacity. Alpha is reduction in capacity, decrease in capacity. And in the manual, they have given us a value for it. which is this much. Got it? Okay. But the alpha means how much capacity is supposed to reduce because of the work zone. How much? This much. And it has a value. Okay. QDR has an equation. What is QDR? Q discharge rate. QDR stands for Q discharge rate. It has an equation, a very long equation, and in this equation we have some factors. Okay. First factor, FLCSI, factor for lane closure severity index. Lane closure severity index. Where is this factor? Okay. What do I need to get the factor? I should know how many lanes normally are on the highway and how many are still open with the work zone. Now you're doing some construction activity, right? So you may close some of the lanes. It can happen, right? So what is the normal and what is with the work zone? If you know these two, you can know FLCSI. Okay? They are the third column because FLCSI has an equation as well. Okay? But we don't need the equation because we already have the factor, right? Why do I use the equation? Got it? Clear? Okay? So just know, you need to know how many lanes are open normally and how many lanes are still open with the work zone. Okay? And then you can get the factor for, this is what? LCSI is what? Something, right?
Very long.
Very long? Yeah. Okay. It's written here. Okay. The next factor I need is the barrier type. Now you're doing some construction activity, right? So you don't want the vehicles to go inside the zone. So you put some barrier. Okay. If this barrier is concrete, the factor becomes 0. If the barrier is made up of concrete, the factor becomes 0. Otherwise, simple, 0 1. Okay. The other types of barriers can be steel, fiber, plastic. Okay. A guy is standing. You have seen those, no? Right? They are standing with the flag. Right? Okay. So that guy also has a factor of 1. Okay. Area type. Area around the highway. If it is urban area, then the factor is 0. If it is rural area, the factor is 1. Urban, rural. Okay. Factor for is not a factor, it's a distance. This one is a distance between the between the lane and the barrier. I told you there's a barrier, right? There's a barrier. At the construction zone, there's a barrier. And after the barrier, you have your road. So what is the difference or distance between the barrier and the road? Got it? Okay. Whatever the distance is, this is my value. Okay. Clear? Okay. The last one is the factor for day and night. Okay. So factor for day is 0, factor for night is 1. Okay. We should have both, right? Agreed or not? We should have both. Day and night both, right? Agreed or not? Don't we have day and night both? Can we have a highway only day? Possible? I have a highway which has only day, no night. Possible? Yes. How? Which planet?
They work on the day only, not on the night.
They work in the day only? Very close. We are not talking about their work. We are talking about our work. What is our work? We are calculating the capacity and level of service, right? Are we doing it for the daytime or for the night? Okay? It has nothing to do what the highway has. Okay? Or when they are working. It has to do with in which hour you are doing the analysis. We do it for the peak hour, right? Abik, need a coffee or something? Now I can bring it. Ramadan is over. Everything good?
Yes.
Okay. We do the analysis for the peak hour, right?
Yes.
Okay. So that can either be in the day or the night. So you have to look at what is your peak hour. Clear? Okay. So once you have Q discharge rate, you will take it, put it in the equation, so you will have capacity of the work zone. Okay, capacity of the work zone. Then the next thing we will calculate is capacity adjustment factor of the work zone. Capacity adjustment factor of the work zone. Okay, this is the ratio between work zone capacity and normal capacity. CWZ upon C. Okay, the adjustment factor is the ratio between CWZ and C. What is CWZ? Capacity in the work zone. What is C? Normal capacity without the work zone. Okay. Where is CWZ? There. Where is C? Okay. So both of them have equations. Clear? Okay. Now work zone also has speed adjustment factor. So I need to calculate the free flow speed in the work zone as well. Okay. What is the equation for free flow speed in the work zone? This is the equation. Okay. What do I have in the equation? I have FSR and SLWZ. I'll start from here. Speed limit in the work zone. Speed limit in the work zone. Okay. Now you had a normal highway which didn't have any construction activity. Now on that highway you started doing some construction, right? So the risk increased or decreased? The risk of accident increase or decrease? Increase, right? So speed limit should increase or decrease? Decrease. Okay, so you may have a new speed limit in the work zone. Okay? Okay. So this is speed limit in the work zone. It may be the same or it may be less. Okay? This is a ratio. This is a ratio. Ratio of what? Normal speed limit upon work zone speed limit. So before there was no work zone, the speed limit could be higher. Now there is a work zone, the speed limit could be lower. So their ratio is FSR. Clear? Now, did we discuss this earlier or not? Yes. Yes or no? Huh? Because he said yes. He was sleeping. Don't trust him. Did we discuss it earlier or not? Yes. We did? Okay. This one. BR means what? BR means what? Best rate, right? BR is what? BR stands for what? Everybody looks at the board. What is the use of these things? Yes. See? They work. I'm asking the question, you are looking there. If the answer was there, what would I ask? I may ask. Okay. FBN. What was FBN? Everybody look at the size, right? FBN. What is FBN? Look at them. How much for this? How much for this? 350. So you owe 350 to your parents because you wasted your money on it. So better use it. FDN means what? Day and night. Okay? Clear? You have things, please use it. Okay? The answers are there. You use it. Okay? And I'm talking about things. I didn't even come to your brain. Which also needs to be used. Okay, so these are already discussed, and we have TRD. TRD stands for total ramp density. TRD stands for total ramp density. What are the units? Ramps per mile. Units are ramps per mile. Okay, how do you find it? You have to count, you have to look at your segment in the map. So you open the map, okay, Google map or whatever map, okay, and then you look at your segment. Let's say this is my segment. From my segment, I'll draw a line 3 mile forward, then come back, draw another line 3 mile backward. 3 mile forward, 3 mile back. Total?
6.
6. Okay. In these 6 miles, I'll count how many ramps I have. Okay. Now take this number, I'll take this number, divide by 6. This will give me TRD. Okay. Clear? Okay. 3 miles forward, 3 miles back. Total 6. Count number of ramps, divide by 6. This will give you TRD. Okay. So this equation will be used to calculate free flow speed of the work zone. Okay. Then you come here, this will give you a speed adjustment factor of the work zone. Okay. So what is this? Free flow speed of the work zone upon normal free flow speed. Okay. Free flow speed of the work zone, this. Normal, you can go and observe it. You can go and do the study for it. Okay, like you did for your term projects. Did you do the speed study for your term projects or not? You did, right? So the mean is free flow speed. Got it? Clear, everybody? Okay, let us do an example. We have a very long term work zone. Okay, now this brings us to another point which I did not mention earlier. Every year, the government does some maintenance on the highways. There is no highway which does not require any maintenance. True or not?
Yes.
You cannot keep on using things without any maintenance, right? This building needs maintenance. Okay? Yeah, these stairs may need maintenance after a few months, right? So there could be a work zone after every few months, right? How long does it normally take? These small maintenance activities, maybe few days, right? So I have 365 days in the year. Out of that, maybe 1 week for maintenance. Should I do adjustment factor for this 1 week? Should I do an adjustment factor for this 1 week? Remember, this is 365 days, and 1 week out of all these days. Should I do all these calculations and factors for just 1 week in the year? We don't. Okay, clear? Okay. We have factors for weather. We have another adjustment factor for weather. Does the weather remain same throughout the year? Do we have same weather throughout the year? No, right? Okay. Sometimes it will rain, sometimes it will be, not sometimes. Okay. You know. Most of the time. Okay. It will be like this, okay. But sometimes it will be rain. Sometimes we may have sandstorm. Sometimes we may have fog. Okay. Maybe 1 month out of the whole year we have abnormal weather, which is not normal. Okay. Because of this 1 month, should I apply adjustment factor? Should I start applying adjustment factor? No, because rest of the 11 months are fine. Clear? So adjustment factors are not done for short-term conditions. Whether they are for weather, whether they are for incident, whether they are for work zone, anything. Okay, so that's why they mentioned in the question, it's a long-term work zone. Some projects take very long, right? Especially the bridge projects. They may take years to complete. So if you have a work zone like this, then it makes sense, right? It is going throughout the year. I should apply an adjustment factor for it, right? Because it is going for the whole year. But if something is finishing in few days, no adjustment. Okay? An incident happened, there was an accident on the highway, the police came, maybe half an hour, everything is clear. No adjustment factor, right? But there is an incident which blocks the highway for the whole year, or which is affecting the highway for the whole year, obviously then I need adjustment factor. Clear? So adjustment factors are not for short-term conditions. Clear? Okay. So the example says a long-term work zone, so we should apply adjustment factor. Okay. We have a freeway with 8 lanes. 8 lanes meaning 4 lanes in each direction. Okay. 2 of these are closed. 2 of the 8 lanes are closed. Meaning how many in each direction? 1 in each direction. Right? Out of 8, 2 are closed. So 1 in each direction is closed. Okay. The free flow speed normal is given. Outside the work zone, what was the free flow speed? How much? 70. Okay. They are using concrete barriers for the work zone. These barriers are right at the edge of the lane. So there is no distance between the barrier and the lane. No distance. Okay. It's in rural area. Critical period of operation of traffic is day. This was what I was referring to earlier. Okay. Critical for who? Critical for us. Okay. Speed limit of the work zone 45. Okay. The speed limit normal 70. Okay. Total ram density 3 times per month. Okay. We have to find out the capacity of the work zone, free flow speed of the work zone. It is not written here, but we will also find out the adjustment factors. Okay. The question only says find out free flow speed and capacity of the work zone. But you will do the next step and find out the adjustment factor as well. Clear? Okay. For the capacity, I'll use this equation. Okay. Now what is unknown here? There are 2 values, right? Which value is unknown? Huh? Alpha or Q? Q is unknown, right? Alpha is how much? 13. Okay, doesn't change. Or even if it changes, okay, we will see the new value. Okay. Now QDR has an equation. Okay, and the equation we need to put some factors. Okay, LCSI, right? The first factor is what? LCSI. Okay. How many lanes in each direction normally? 4. Okay. How many are open in the work zone? So 2 lanes were closed, right?
3.
Okay, so 3 are open. 2 from both directions. Meaning 1 here closed, 1 there closed. Okay, so 3 are open. Okay, so 4 lanes. Where is it? 4, 4. Okay, here only 1 lane is open. Here only 2 lanes are open, and here 3 lanes are open. Right? This is my case. So my FSCSI is 0.44. Okay, write it somewhere. Okay, next factor is barrier type. Okay, what type of barrier we have? Concrete. So the factor is 0. Okay, next factor is area type, urban or rural? Rural. Okay, so the factor is 1. Okay, how much distance between the barrier and the road? 0. Okay, so this is 0. You will put it 0. Exactly 0. Okay. Day and night? Day. Okay, factor is 0. Okay, so this factor is 0.44, barrier 0, area 1, this one 0, this one 0. How much is it? How much is my QDR? Sorry.
1760.
1760. Okay, now everything is known, so you can calculate the capacity of the work zone as well. How much is that?
The 13.4, we should substitute it as a percentage.
See, okay. See, you are subtracting from 100, right? You are subtracting from 100. So what should I subtract from 100? 13.4 or 0.134? 13. Because it is 100. Got it? Clear? So you have to see, look at the equation. Okay? You may forget it later on, but look at the equation. I'm doing something from 100. So it will remain from out of 100. Yes, how much?
2032.
203? 32. Okay. Okay. Now the free flow speed of the work zone. Okay. First of all, I need the speed limit in the work zone. How much is given? The speed limit in the work zone. How much? It's written in the question. How much is it? 45. Okay. Speed limit in the work zone. Now we have it. Okay. Then I need to calculate FSR. Okay, which is normal speed limit upon work zone speed limit. Okay, both are given. This one is 45 and this one is 70. So how much is it?
1.5.
Okay, TRD is also given. Is it 1.5? Okay, TRD is also given. How much is it? Total gram density, how much? This is what she asked. You are subtracting from what? 100, right?
Yes.
Now you tell me 13.4 or 1.134. From 100. 100 is 13.4. Okay, TRD is given 3. Okay, anything else which you need? SCSI we already used. Same value. Okay, factor for barrier, it was concrete barrier, you already know what to do. Factor for day and night, it was daytime, you already have the factor. Okay, so how much is the free flow speed of the work zone? Yes, any question? No? How much is it? FBR will be 0. FDN for daytime it was also 0. TRD is 3. Everything is there.
55.4.
Hmm?
55.4.
55. Okay, this is what they were asking in the question. Find out the free flow speed of the work zone and the capacity of the work zone. We already did that. Okay, but we will do the extra step and calculate this one and this one as well. Okay, Now to calculate this, I need this capacity of the work zone, which I already did. Okay, in this question I already did it. Okay, I need the normal capacity now. Okay, so for normal capacity, this is the equation. Okay, free flow speed 70 is given. Okay, so how much is the normal capacity?
202.2.
Not possible. 2200.
2400.
240. Okay, so my work zone capacity was 2032. My normal capacity is 2400.
0.85.
So the capacity adjustment factor for work zone 0.85. Okay, now for the free flow speed, speed adjustment factor, work zone. Okay, I need the free flow speed of the work zone, which we already found from this equation. Okay, and I need the normal free flow speed, which is given in the question 70. Okay, so this one is 55.4 divided by 70, which 7. Clear? Yes, Najiba. Clear? I mean the picture is clear. Any questions? Sure. Okay. So this is how we find out the capacity and speed adjustment factor for the work zone. For all the other conditions we have tables. Okay. When you are doing the analysis for the level of service, you need to know some conditions of the road. They are calling them prevailing conditions. Prevailing means existing, current. Okay, prevailing means existing or current. Okay, what are the conditions you need to know? You need to know the lane width. Okay, you understand lane width, right? You need to know lateral clearance. Okay, what is lateral clearance? From the lane to any side object. From the lane to any side object. Okay, and in some cases, after the lane, we have the yellow line, right? Yellow line indicates what? Emergency lane, right? This is not counted. This is not counted as a lane. This is not part of the road. You guys think it is, but it is not. Okay? So that's why they have to put the placement there to explain to you this is not the road. Okay? So this emergency lane, we call it the shoulder. This is not considered part of the road. So your lateral clearance starts from the yellow line. After the yellow line, if you have the emergency lane is the clearance. Emergency lane is part of the clearance, not the road. Got it? There. And in the book you will see it is called as shoulder. So shoulder means the emergency lane. Okay? And if it is there, it is part of the clearance, not part of the road. Got it? Okay. Type of median only for multi-lane highways. Type of median means 3 things. I will show it to you. Okay. But only for multi-lane highways. Okay. We don't need to know the median condition for freeways. Why? Because it is fixed. Okay. How it is fixed? Freeways always have a median. That's it. There is no freeway without the median. Got it? Okay. If you say it's a freeway, it doesn't have a median, you are making a mistake. Okay. Either you are missing the median, or either it is not the freeway. Got it? Okay. So only for multi-highways we need to know the median condition. Okay. Then we have frequency of ramps. We use ramp density earlier, right? 3 miles forward, 3 miles back, total 6, divided by ramps divided by 6. Okay. So you need to do this only for freeways. You need to do it only for freeways. Okay. For multi-lane highways, we have access points. Okay. Now, what is the difference between? Okay. First of all, keep one thing in mind. Freeways don't have access points. Freeways don't have intersections. Got it? Freeways only have ramps. Got it? Okay. So the condition is fixed. No ramps. Only ramps on freeways. Nothing else. Okay. So ramp density is only for freeways. Okay. Multi-lane highways are from the other category of uninterrupted, which have intersections. The intersections are more than 2 miles from each other. Okay. So on your segment, you can have access points. Now, there is a difference between access point and intersection. There is a difference between access point and intersection. Okay. So you are I have made 2 things here. This one. Okay. Let me call this 1. This is 2. Which one is an access point? Which one is an intersection?
2 intersection.
Huh? 2 is an intersection, right? Okay. And 1 is access point. Okay. I did not make one more thing here, which is this one. The access point does not have any signals. It is unsignalized. Access point is always unsignalized. Okay. And what is the other difference? Why did you say this one is the access point?
Has median.
It has median. Anything else? That one could also have median. I didn't make it, but it could have a median. Yes. The other one could also have a median. What other thing made it into an access point?
Car decides where to go.
Huh?
No signals.
No signals? Anything else?
Only 2. Only 2.
Only 2 what?
Only one and one open.
Yeah, something like this. There is no left turn from where you are coming. For the side road, there is no left turn. Okay, so this is what makes it into an access point. Access point means entry. This is an access point. This is an access point. So from this access point, I can enter this road. Okay, not the next road. Got my point? Okay, so access point is always unsignalized. And so it's always from entry from minor road to one's direction. That's it. You cannot cross it. There is no crossing. On intersection, there is a crossing, right? Okay. So access point is that point from where you can enter and exit the highway without any signal. And it's always for one direction. There is no crossing. Clear? Any questions? Okay. So you need to count how many access points you have on your segment, and you divide by the length of the segment. You get access points per mile. Okay. So we need ramps per mile and access points also per mile. Okay. And as I said, you cannot cross. So you will only count access point in your direction, because this is the only one which can affect that, right? I have an access point on the other side, but this does not affect me. That guy cannot cross. Got it? Okay. Another name for these access points in Bahrain is it means what? This and this. What does it mean? call them right in, right out. Okay, so freeways cannot have access points, and multi-lane highways cannot have ramps. So for freeways, we do ramp density. For multi-lane highways, we do access point density. Okay, the other way is not possible. Okay, you cannot have access points on freeway. You cannot have ramps on multi-lane highways. Okay, we need to know the percentage of heavy vehicles on the road. How many heavy vehicles are on the road? Okay, and the last thing is what type of drivers we have, and what type we don't mean male, female, and young and old. We mean new or familiar. Okay, this is what we need to know: new or familiar drivers. Got it? This is a list of conditions we should know before starting our analysis. What is my lane width? What is my clearance? What type of median I have if it is a multi-lane highway? How many ramps I have per mile? How many access points I have per mile, depending upon the type of highway. Okay? Percentage of heavy vehicles in the traffic and type of drivers we have, new or familiar. Got it? Okay? So these all these conditions are required for the analysis. Any questions?